Hi, I'm Charlotte O'Brien, Director of BioBamboo, an organization set up to look at what bamboo could do to help with the problem of global warming. CO2 is measured right here in Hawaii every month. It has been done since 1958. As you can see by the chart, we go up, up, up. We're increasing at a rate of about 2 parts per million every year. Right now at about 390 parts per million, heading towards 450 parts per million, which is considered the tipping point. That gives us 25 to 30 years to begin to resolve this problem. Climatologists have said that we need to replant the world's forests, rejuvenate the world's soils, draw down CO2 levels, and reduce our emissions. NASA's Goddard Institute has given us a mandate of drawing down 36.85 gigatons per year for 30 years to return the Earth to balance. That is an enormous amount of CO2. CO2 can only be drawn down by natural forces. There's no magic vacuum cleaner out there that's just going to pull it down for us. We must work in conjunction with nature. Doesn't matter how much we reduce our emissions, we still have to pull down what's there or global warming will continue to increase. Buckminster Fuller encouraged us to solve the problems that he saw coming towards humanity by using systems that were integrated and mimicked nature herself. The BioBamboo system does just this by drawing down CO2 levels, environmental restoration, microclimate balancing, rural poverty alleviation, soil rejuvenation, reforestation with bamboo, new technology deployment, food security, erosion control, and bamboo as a building material. Bamboo is a climate change hero. This is bamboo right here in Hawaii. That is a 6-year-old plant. It has more than 100 culms, and as you can see, it's also very tall. Bamboo comes out of the ground at its full diameter. It takes about 2 months to reach its full height, and then it takes after that 3 years to mature. So you're actually harvesting a culm after just 3 years. The beautiful part about bamboo is you're only harvesting 25 to 33% of each plant in any 1 year. That leaves the roots and the majority of the culms to hold back erosion, which makes it particularly wonderful for growing along rivers and on steep hillsides. Bamboo also balances the microclimate because of its mass. Bamboo is also a pioneer plant. You can see that these plants have been planted in the middle of a lot of weeds, and 5 years later, with no chemicals and no hand weeding, it looks like that. This also is in Hawaii, out at Whispering Winds Bamboo. Bamboo has the same caloric value as wood. According to Stanford University, there are 1.8 million square miles of abandoned croplands. That's nearly 7 times the size of Texas. Bamboo can grow on abandoned and marginal lands that cannot be used for agricultural purposes, meaning that it is a biomass crop that will not compete with food production. The United Nations has proven that bamboo can restore depleted soils. Dr. Mi Han of Saigon University decided to prove that it could also grow in some of the worst soils in the world, choosing the Iron Triangle of Vietnam, an area that was bombed repeatedly during the war. And after 3 years, the bamboo looked like this. Those little bumps that you see down at the bottom, that's actually earthworm castings, because bamboo has a way of rejuvenating soil that the earthworms are then drawn back into it. With 1,200 different types of bamboo, different species, there are some that are drought resistant, giving great hope for the sub-Saharan desert areas. Bamboo also produces food at the rate of 1 ton per acre per year. There is a lot to love about bamboo. Over 1 billion people live in bamboo houses, all different shapes, using it for fencing. But because of a technology that came about in 1955, we are now able to preserve bamboo in a simple technology so that now even millionaires can live in beautiful bamboo houses. They can be built in factories such as this one that I used to work in Vietnam. Many architects around the world are working with bamboo to bring it into the world economy as a building material. The Chinese are specializing in taking bamboo and making it 3D dimensional and building 100% bamboo houses from that. Luckily, many builders are also working on using bamboo for the common person, building bridges, simple houses. This is in Costa Rica, India, South America, Colombia. It can be used to build school buildings. Yet with all the advantages that bamboo gives us, it's disappearing. Now, why would that be? It's because bamboo is not tied to the world economy. People grow bamboo, they harvest bamboo, they bring it down rivers on rafts that they've made out of bamboo. They drag it on mules. They bring it by bicycle. They bring it to the traders, who then put it on trucks and transport it a very short distance, usually to places that make things like chopsticks or something that is unfortunately polluting. Here you see a very large sawdust pile by a river that's either on fire or giving off methane or floating down the river. Here you see in China, in this particular town, they produce 2,000 tons of bamboo sawdust a day, put it in simple boilers, and then allow it to pollute. So it's time to think out of the box, like Buckminster Fuller would. The question is, what would it take to make farmers in the tropics and subtropics spontaneously plant more bamboo on their marginal lands? And the answer is, give it a good market price. Tie it to the world economy. So what would tie bamboo to the world economy? Making it a designated biomass that replaces fossil fuels. And then, of course, people will plant it. There's a new cutting-edge technology that can convert bamboo biomass to carbon-negative biofuels. It's called pyrolysis. There are 7 different types in the world. We prefer the auger style. It can take bamboo biomass, run it through a machine that can be put into high-cube 40-foot containers and shipped any place in the world, plugged together in a plug-and-play sort of system that can then start producing not only thermal energy for industry, but also electricity, biofuels, and most importantly, biochar. I say most importantly about biochar because it is the black gold of climate stabilization. Biochar with microbes sequesters atmospheric carbon for millennia. It's a powerful soil amendment. It increases water holding capacity. It retains nitrous oxide in the soil. Nitrous oxide is 210 times as dangerous as carbon dioxide. It rejuvenates soil life. It increases food security. It increases beneficial microbes. And those microbes further sequester carbon in the form of glomalin via the liquid carbon pathway. This is an example in Colorado of Hope Mine, which could not grow anything because of the mine tailings. But 13 months after they applied biochar with microbes, it's begun to grow vegetation again. Biochar can also be used in smokestacks to reduce the emissions. And once it's dirty, it can be taken out and cleaned through a pyrolysis system again and reused. Biochar makes soils rich, as you can see the 2 different soils here. Biochar sequesters carbon for 1,000 years. That is 85% pure carbon. It was once in the atmosphere. Now it's sitting in a form that will sit in the soil for over 1,000 years. The reason biochar is so effective is because it has a very high surface area that allows microbes, particularly mycorrhiza, to live inside the biochar. It makes mycorrhiza flourish. Mycorrhiza is a microbe that grows in combination with 90% of all plants. It's a symbiotic relationship in which the plant over photosynthesizes by 40 to 50% and exudes those carbohydrates down to the mycorrhiza. The mycorrhiza then go out into the soil and bring back nutrients that the plant would otherwise not be able to get. When there are drought conditions, mycorrhiza can go out and bring back water. But perhaps most importantly for climate change, mycorrhiza sequester carbon in the soil through a system of taking the carbohydrates given to it by the plant and turning it into glomalin, which is what gives soil that wonderful tilth, making more room for additional water to soak in when the rains are heavy rather than rolling down to the valley. So this glomalin is a form of carbohydrate in the soil. In soils that are farmed sustainably, it has been recorded as much as 32 tons of carbon dioxide have been sequestered per year per hectare. This is an essential part of our system. Biochar is easily added to soil. And in the experiments that have been done around the globe, biochar has the ability to double and sometimes triple crop yields. In this slide, you can see this young man has a cornstalk in his right hand with lots of roots. In his left hand, very few roots. The difference is biochar with microbes. It's easy to add biochar to the soil. It makes it nice and fertile, increasing crop yields. So that's where the exponential drawdown of CO2 comes in our system. We have our main pyrolysis system that takes in about 120 tons of biomass per day. And from that, there's enough biochar generated in 1 year to treat 11 square miles of croplands. The increase in the biomass of the crop yields of that 11 square miles is then enough to make more biochar in farmer retorts locally positioned to cover another 3 square miles of cropland. And from that, again, through farmer retorts, another square mile. So you get this exponential drawdown of CO2. A farmer retort is a simple brick kiln oven that can be built out in any place. And each brick kiln oven can service about 200 acres per year of additional biomass from crops. We've done the math. There is an exponential drawdown. After about 35 years, you've drawn down 1/4 of a gigaton in that year. So the system is this. The CO2 goes into the bamboo. It also goes into the ground under the bamboo. Some bamboos are nitrogen fixers, as well as the companion plants that are also nitrogen fixers. The bamboo is used as a biomass that goes into pyrolysis that produces electricity, thermal energy, bio-oil, and biochar. The biochar is put on agricultural fields that then increases their crop yield, and that additional increase goes into farmer retorts that make additional biochar, and that additional biochar goes in onto additional farmer fields, so you have an exponential drawdown. So carbon is sequestered in 5 ways: in the roots and soils under the bamboo, in the bamboo biomass itself that becomes biochar, in the soil under the agricultural fields, and in the biochar that comes from the resultant increased biomass from the crop fields, and then also by replacing fossil fuels. So if people are silly enough to still keep cutting down old growth forests, which often kills all the mycorrhiza because mycorrhiza cannot live without a host plant, and they cannot live when they're subjected to the sun. It's happened even here in Hawaii, where now we have desert where once we had beautiful forest. Biochar, together with microbes, gives us hope of bringing places like that back into fertility. So another Buckminster Fuller moment. The question is, who wants to do the work? Who will do the work to draw down carbon dioxide? Who will help nature do this for us? And the answer is, there happen to be about 3 billion people on the earth that are either unemployed or underemployed. I call it the bamboo culture of people that tread lightly upon the earth. A lot of their work is handwork, but from my extensive time in Vietnam, I find them to be very happy at their handwork. This is a school teacher watering his bananas with his wife. They use infrastructure that's been put there by their ancestors. This is actually one of the best paying jobs in this entire region. It would help this area if some of the outside income from the world economy were to come into it without changing it too much. One reason the bamboo culture can live on so little money is that a house costs $3,000. Oftentimes people go out and collect their own rocks to make that house, or someone brings them rocks down the river that were collected upstream. Rocks are also used to make roads by hand. I rode my motorcycle about 200 miles that day, and every place I went, people were building roads by hand. Of course, the roads don't have to take a lot of traffic. People live pretty simply, but quite joyfully. But I'm told by my good friend who's a lawyer for USAID, she was born in the villages. She said that her cousins do not want to move to the city. They prefer to live in the villages, but they need more income there. And this system of paying people to grow bamboo to draw down CO2 would help them stay in those villages where they want to stay with their families. And anything that we can do to help people stay in those villages, in that farming culture, is preferable to moving to the cities. So our sister organization, Carbon to Soil Inc., is a mission-driven business combining new technology, market forces, and small farmers worldwide to exponentially draw down CO2 levels while rejuvenating world soils and supporting rural economies. We believe that bamboo is crucial to reversing global warming. It has, as you have seen, many environmental benefits. It replaces timber products. It draws down carbon all by itself, but most importantly, it creates the biomass, the designated biomass, that then creates biochar while replacing fossil fuels. This increased biochar then increases farmers' crops, which creates more biochar, and we begin an exponential drawdown. At the same time that we are rejuvenating badly deteriorated environments. We need support. We'd like yours.